Hey everybody. So now we're going to dive into a binomial distribution. We spend the bulk of this course on what's called the normal distribution. And so I just want to highlight the fact that there is another kind. There's actually several other kinds of distributions. Because this is an intro to stats, we're just going to talk about the binomial one because it's the second most common distribution. All right, so an example of a binomial distribution is like a true-false test. A binomial distribution, bi means two, and so there's only two options. You get the test correction correct or you get it wrong. You're male or female. You made it to class on time or you did not make it to class on time. You get heads or tails on the coin. Like there's only two options. Binomial distribution was created by Bernoulli. Not like a super uber important fact other than, on Jeopardy. And so, all right, and so there's only two possible outcomes, a success and a failure, and the probability of success is called P. And so these are some examples. Flipping a coin, if there's a product is defective or it's not, you make the free throw or you don't. And so, like I said, there's various kinds of distributions. We focus on the normal one, and then this one's binomial one, but there's Poseidon, geometric, so on and so forth. The trials are independent, meaning like they don't depend on each other. So if I get ahead on one coin, if I get ahead when I flip the coin, and I flip it again, it doesn't matter what I got on the first try. All right. And so here we're just going to decide if this is a binomial experiment or not. And so we select 20 university students and record their class rank. And so this is not, because you can be a freshman, sophomore, junior, senior. You'd maybe be a grad student. Okay. If you ask those 20 students about their gender, it is, because you can be male or female. 5 cards from a deck without replacing and recording if they're red or black. So all we're looking for is not if it's a face card, not if it's a number card, if it's just red or black. So yes, because it's red or black. By asking 5 students if they're on the dean's list. That is because you're either yes on the dean's list or you're no on the dean's list. And recording the number of children in 50 selected families. All right, this is no, because we're not asking the gender of the children. We're saying how many do you have? You could have 0 kids, you could have 1 kid, you could have 2 kids, you could have, 40 kids. All right, it goes on forever, like the options. All right, so there's some new symbols. That's the hard part of stats, right, guys? Okay, so there's new symbols that we need to learn, and we're going to come back to this P and Q in another chapter. So it's kind of important to learn. It's not like we just need it for this section. All right, P is successes. So I made 7 of my 10 free throws, or 2 of the 12 calculators are defective. All right, Q is the opposite. So if I made 7 of the 10 free throws, then I did not make 3 of them. Or if 2 of the 12 calculators are defective, then 10 are not defective. Okay? And so when you add P plus Q, that's a Q, you get 1, as in like all of the items. Or if you make, you could also think of it like this, P plus Q is 100%. So if 40% of the class is males, then that means 60% of the class is females. All right, N is still the number of trials. We've been using, like N is the sample space, so same concept. And then X is how many successes there are. All right, so we have this formula. No need to like freak out, okay? We just have another formula and it looks crazy, but it's gonna be fine. All right, so I'm gonna show you 3 ways how to do these types of problems. I'll show you the formula right here, the distribution table, and I'll also show you the calculator later on. And then you decide which way to do it, unless I specifically say, hey, use the formula, use the calculator, use the table. All right, if we look at this piece right here, this we learned in the previous in chapter 4 on probability. That guy is the exact same as in combination X. So we can replace that. And we could write n cx and then p of x q of n minus x. All right, and so it doesn't look as scary, and then most of this we just type in our calculator. I'm gonna write that down. I don't always remember that. All right. Okay, so let's do this problem. Suppose a free throw shooter shoots 3 free throws, 70% accuracy. Is this binomial? Find the variables and find the probability of each. All right, so we need to find P, Q, N, and X. Those are the variables from the formula. The formula was N, C, X, P, X, Q, N, minus. All right, and this is a binomial distribution because you either make the shot or you don't make the shot. All right, P is 3. That's how many successes there were. I'm sorry, that's not. Hang on, where's my? Is the probability. 70% accuracy probability. All right, and then Q is going to be 30% because you just subtract from 1. 1 minus 0.7. N is how many. So they did 3. And X, it doesn't tell us in this particular problem how many were made. Okay, we're not going to do this piece out. I just want you to know how to find the stuff. So it said like let me show you another example. Here we go. All right, survey found that, here we go. 1 in 5 Americans says that they have visited the doctor. 10 people are selected, and we want the probability that exactly 3 will have visited the doctor. P, Q, N, X. And I always write our formula, N, X, P, X, Q, N, minus X. All right, so P, 10 people are random, so that's how many there are. We want to know exactly 3. And it says 1 out of 5 Americans. So 1 out of every 5. And then Q will be 1 minus 1/5. And so that's 4/5. And then I'm just going to pop in those numbers into this. So 10, C, 3, E, 1/5, the X to the 3rd, Q is 4/5, and then n minus x is 7. Okay, and so show you. All right, so it was 10. All right, 10. So I typed 10. Okay. This calculator. Let me get a different calculator. Pause. Okay, so I got a different calculator so you could see it better. All right, so 10. And then remember to get that C, we push math, and then we go over probability, go down to C, and then we're going to push 3. All right, type parentheses around it, because then we need to type parentheses 1/5 to the power of 3. Okay, and then we had 4/5 to the power of 7. All right, and so that's what we get as our answer. 0.20. What happened here, buddy? 0.20. What? Wait a minute. My stuff went away. Oh, I was on the right slide. Silly. All right, so that means 0.20 is the same as 20%. All right, and so that means that the probability that exactly 3 will have visited the doctor last month is 20%. All right, let's do this one. A survey shows that 80% of math majors watch The Big Bang Theory. In a random sample, 80% of 15, what is the probability? Okay, and then we're going to have these different scenarios. Okay, so 80% is P. That means Q is 20. And then N is 15. All right, so exactly 12, that means our X is 12. And so we do 15C12, and then 0.8 to the 12, 0.2. Okay, and 15 minus 12 is 3. All right, and so I'm going to type that in my calculator. 15, parentheses, 15, go to math, down to probability, 12, parentheses, open another parentheses, 0.8 to the 12, 0.2 to the 3. All right, so here we are, and I get 25. So it would be 0.25, 25%. 0.25. So 25%, the probability that exactly 12 watch the show is 25%. Okay, I'm going to stop this video, and in the next video I'll do the next problem.